Hey guys, welcome back. So here's an episode of shit you did not subscribe for, but I'm going to show you anyway. So this is my old laptop. It's a MSI GT70, manufactured in 2013. So this is a classic, and I use this thing every day. I know what y'all are thinking, why don't you get a better laptop? Well, I had this custom built. So this was about a $2,000 gaming laptop back in 2013, but I spent about another $1,000 getting it upgraded. So it's actually pretty nice. It had triple solid state hard drives, 32 gigs of RAM. They upgraded the process. I spent like an extra $500 upgrading the processor, upgrading the cooling systems, all kinds of stuff. And I've actually never really had a hardware problem with this. Well, with an asterisk. But anyway, a few years ago I tried to get, let me just get to the point. Shit's overheating and it's slowing my computer down. Now, for basically every year or every 2 years, I send those to a computer place and have them clean it, do any maintenance, and, just generally try to keep it healthy, which is probably why it's lasted this long. But the last couple of times I took it in, I had a complaint that, hey, it's running hot because I can see my processor throttling. Basically, the fan's always running fast and the processor keeps slowing down, and I didn't know why. So the last 2 times I brought it in, I specifically told him, I was like, hey, can you check it out? Check the thermal paste or redo the thermal paste, clean it really good, whatever. So 2 times ago, I get it back and it was still terrible. And I dealt with it for about another year, and then I took it to a different computer place. And I told them, I was like, hey, the last guy, he didn't do a good job. Can you do it? And he took it apart and he said he found a couple things. They redid the paste and it was good to go. And I get it back and it was a little bit better. But it was not really right. It's still throttling. I mean, my fan runs at like 70-80% speed just sitting there doing nothing. And as soon as you try to do anything, you see the processor constantly the frequency's going down and the temperatures are hitting the 100°C limit. So I finally decided, I was like, well, I guess I could take it to a third place, or maybe I'll just take it apart and see if I can figure it out. So this has been about not even a year since it was taken apart. And for those of you that are still watching, and maybe y'all already know how this works, but basically processors have these things called heat pipes, which if I flip this over, see that little square? That goes against the, I believe that's the graphics card. So that little solid piece of copper gets hot, the processor touches it. If you look closely, you can see that was too much heat sink compound, but you can at least tell it was kind of making contact. You can see up there where the copper is, it was making good contact. Over here where you see that thick paste, not so much. That's the one for the graphics card. Now let's go to the one for the processor. First of all, you'll note the graphics card one is humongous. The processor one, not so much. And I'm pretty sure this is the graphics card. So these are the 2 processors. Even though this one's bigger, I'm pretty sure it's the graphics card, because if you look at the things coming off of it, are video. So, the fact that you got 3 different video ports coming out right there, that's pretty much got to be the graphics card, which means this one's the processor. And this is on the motherboard, whereas that's on like a separate card. So I'm not a computer expert, but anyway, I'm 99% sure this one's the processor. Now this one's tiny, and I want you to look at this. Look how thick the goop is. It never squished out. Which is a bad sign. And then when I flip this over and look at the heatsink, same thing. Look at this. Just a big old pile of goop. You can't even see copper. And when I was taking this apart, it wouldn't come apart correctly. I watched a video on how this comes apart, and these 2 pieces should come out one and then the other. And I had a hard time they were stuck together. And what happened, I figured it out. These 2 pieces were still, let me try to show you guys. This goes like that. So basically this heat pipe has some tape, thermal tape or whatever that is, thermal pad, that sits on top of this. And that helps that some of the heat that comes out of this processor catches this little pipe, runs over here. Well, I guess it has to run all the way. So I guess that helps a little, but probably not a lot. But these 2 were stuck together. And it was these things. These are what were stuck. Okay, why does that matter? Well, let's come back over here. We'll start with these are what anchor it to the board. See this right here? Like I can wiggle that, or I can try to wiggle it, it won't move. But these 2 were not installed in the board. They came out with this. And it was obviously like that before. When I took this apart, you know, I could kind of tell this felt loose. And the fact that this compound is all goopy looking and thick really shows me that that had never made contact. This one had. You can see how it got squished thin, and we saw it on the heat pipe too. That's just not the case with this one. And the fact that they put it on so thick kind of tells me that they knew it wasn't making good contact, so they just put on some extra pad, some extra compound to make sure that something was touching. So what does all this mean? Well, basically they knew that these pad things were broke and they did not fix it. Now, to be fair, I don't know if I can fix it either, because I'm not sure how that even works. But I'm going to at least attempt it. These, just by judging, these look like aluminum. Maybe they were knurled. If they were, I'm guessing they just press into the board. It's kind of what it looks like. So that might be very, very difficult to fix. I really don't know, to tell you the truth. I haven't got that far. But at least I know that now I'm not crazy. And I, you know, 2 different computer places, neither one of them told me what was wrong. I assumed that they were competent enough to know, but they didn't tell me. So this is one of those cases where DIY at least told me the problem, even if I don't know how to fix it. Also, you can see that this is called some kind of thermal pad or thermal tape. This is on some MOSFETs, and then this guy has another row right there that catch those MOSFETs. This is all the original tape. This stuff's all dusty, dirty. Like, you can see the edges are just covered in dust. There's no way that that was replaced less than a year ago, because it's just, you know, it's the dirtiest part of the board. So there's definitely, that's old and never been changed. So I'm going to replace that. I got to order it, but I'll replace it. And at least I know what the problem is now. Now I know the problem is this heatsink's literally just not touching the processor, and that's why my processor sucks. Now, how do I fix that? I don't know. We got to look into that, because maybe there's like a Google that'll tell me how to fix this, you know? Hopefully I can figure out something. But anyway, thought that was kind of cool. Show you guys that sometimes you got to do a little troubleshooting yourself to get to the truth. Because I've been, like I said, I paid 2 different computer shops to fix this. Neither one of them fixed it. Both of them told me they fixed it and they charged me to fix it. But neither one of them fixed it, and neither one of them told me about this problem. So, yeah, you know, it's kind of what you get. Oh, and last thing I'll show you. This is the heat sinks they cleaned. So what it looks like, and I've already cleaned these myself a little bit, but this top row was basically just mostly plugged with dirt. In fact, it's still got quite a bit of dirt in it. But what it looks like is they just took a can of air and kind of sprayed it off a little. They didn't put a whole lot of effort into cleaning these. So since it's my computer and I do care about it, I'm going to do a better job of cleaning this. And I'm probably going to actually do like soap and water and actually spray this and get the, because what happens with heat exchangers is you get like a layer of dirt. For you guys that have ever, you know, this is a car channel, y'all can see that on radiators. You can actually take a radiator and like spray it with soap and water and rinse it out, and it'll work a little better. They build up like oils and thin films of dirt that's like an insulator between the heat exchanger. So these can likely get a little bit better just from cleaning, but that wasn't the root cause of the problem. The root cause was this processor. So, and I kind of had a feeling, because the graphics have been doing pretty good, but the processor has been terrible. So now I know why. So anyway, I ordered thermal paste. It'll be here like tomorrow. I still got to order some of this stuff because I didn't even know if I needed it. And I was like, you know what? Let's just look and take it apart. So I'm going to buy some of that. And I guess I'll be using my phone, but I'm going to try to Google search how to repair these. Because now that I know what's wrong, I'd like to actually fix it. And my guess, not being a computer nerd, but I'm going to assume this is called a motherboard. And I don't want to change a motherboard if I don't have to. So hopefully I can figure something out for a repair on these. Oh, and last cool thing. So they did clean the fan. I don't think they did a perfect job, but they cleaned it. It's not that bad. But this thing is supposed to have 4 screws holding it. This fan requires 4 screws. It only had 1. So 1 out of 4. So I thought that was kind of funny. But I haven't looked around too much to see if I find any other issues, but oh well. I'll do the best I can and get this thing back together. But at least now I know what the real root cause of the problem was. So anyway, you guys take it easy. Okay, so I'm fixing to show you guys some heat exchangers. We still got to figure out how to do this repair. Some Google searching has not showed up anything, so really not sure. But I did find out you can't really solder to aluminum without a bunch of special stuff that I don't have. But I wanted to show you, so I paid these guys to clean all this stuff, and I don't think they did a good job, or I don't think they even did it. I think they just blew it out with an air can. So what I just did was I cleaned this one, and I didn't use anything fancy. I just used soap and water in my kitchen sink. But here's the old one, and I've blown air through it, and I've tried to, basically with a duster, kind of like cleaned it out, and that's what it looks like. Now compare it to this one after hitting it with water. I don't know how good this is going to show up, but I mean, you can see right through this thing. Like, there's just a buildup on the fins, probably like, 8 or 10 years of dust, and it just makes the gaps look thicker. Or the gaps are thinner, like the metal's thicker, but the metal's not thicker. It's just that there's a layer of dirt built up on it over the years. So you can literally see when I come over to this one, it's a better setup. It's more open. There's definitely going to be more airflow going through this than that other one was. So, also, it looks so much nicer just cleaning it, comparing that one looks all nasty. So, anyway, just thought it was interesting. You only get so much when you go to a computer place, apparently, or at least the ones I went to. Also, so this one screw is the one that was making contact, and if you look at this pad, there's actually a sharp edge where that one screw was pulling down and like digging the processor into the heatsink, and then just nothing over there. Just nothing. So there's physical evidence that it's been that way for, some time. So hopefully we'll be able to fix it. We peeled all the, I guess I'll show you this. See all this tape? That's like thermal tape that goes on kind of like all the main chips on the here, and I'll show you something there in a second. So anyway, we peeled all that. We ordered new tape. We're going to replace all that. There's some that goes over here. These are presumably power, well, it says resistors. I don't know. Something that probably helps the processor be happy, so we're going to change all that. And there's one thing I noticed. So I caught this right here at the end, right when I was about to clean everything. So I was looking at this, and as I was cleaning it, I noticed there was a sticky residue around this metal pad. And you know what I figured out is that I believe this had thermal tape all the way around that. And then when it was on here, you had thermal tape bonding this die all the way around to help cool it. I think that was there like sometime in the past, and the last guy or the guy before him or whoever, somebody at some point just deleted all that and got rid of it. So for better, probably for worse, I doubt that helped anything by deleting thermal pads. So we're going to also put all that, presumably it was there because there's adhesive all around this. There was adhesive where someone scraped it all off. So, but they didn't clean it all the way. Imagine that. So we're going to put all that tape back the way it's supposed to be, so that then when we stick it on here, you'll have, your thermal compound, you'll have your pad all the way around that's bonding to the board, I guess. I don't know how much that helps, but it looks like it was done that way from the factory, so we're going to do it that way too. And anyway, this guy over here, all those little parts are the parts that had tape on it. We're going to go clean this heat exchanger next. And then this piece of tape, this is the one that actually bonds, pull that off. That piece bonds to the top of this, so that any heat coming off the processor can go from here to that and then loop around long ass way, but get over here and help dump some heat that way, I guess. So we're going to change that piece as well. So really, looks like we're kind of good to go. We just got to wait on the materials to come in, the paste and the pads, and then we got to figure this out. And right now, I'm going to do some more Googling. I haven't come up with an awesome way. One way would be to change the motherboard, but I don't know how much a motherboard costs, and I'm not really a computer person, so I'm not real comfortable taking all this apart and then having to put it back together. So I guess that's our worst case scenario. If I just can't seem to fix this, I'll put it back together the best I can, and then I'll probably just have to buy a motherboard and pay somebody to change it. But I'm thinking maybe JB Weld. I still haven't figured out what they did from the factory. It kind of looks like they soldered it. I'll try to zoom this in and show you guys. See, there's like metal. It almost does look like there was some type of, metallurgical bond there, and I guess I don't know why they failed, My guess would be a shop that was working on my laptop probably calls that, just a guess. But, oh, my video stopped. Okay. But yeah, we're gonna do something, probably epoxy, and try to fix that. So, we'll see. Okay, so I wanted to show you guys a little bit about the design of this part and why cleaning this is going to make such a big difference. So, heat transfer, copper conducts heat better than aluminum, right? So, and with heat transfer, it's kind of like a distance thing, right? If you got to travel twice the distance, well, it's going to be, half as much heat transfer, more or less. So I want you to look at the design of this. Let me try to set this where it can... I should have set this up better. But anyway, it's kind of obvious that the top is really short, the bottom's really long, right? A side view really shows you what I'm talking about. That top is probably, just barely over 1/8 of an inch. The bottom is a 1/2 inch long. So the bottom is about 4 times longer distance, right? So, but the bottom has more, you see the fin density starts out like, just from the copper down, you see there's a lot of fins, and then it kind of opens up and there's more room for airflow. That's not an accident. That very first section where they got lots and lots of fins, there's a lot of heat transfer happening there. And you see it on the top too, but you notice how short it is. Now, when this was installed in here, I'm not going to put it in all the way, but when that was in that duct, this fan right here blows air on it. So this top section had a tiny little strip of foam, which it was mostly destroyed, but it used to have a tiny piece of foam here. And what that did, obviously, is sealed it so that air had to go through this section and not around it, right? And then the bottom had a really wide section. This entire gap here had foam as well, which sealed it. Again, same reason, air goes through the exchanger instead of around it. Now, the point I want to make is this top section was mostly plugged up with dirt. This foam that was up on the edge to get it to seal had built up dirt in front of it, and the dirt had like falling into the front of this and just clogged it up. And this was actually true if we go to the one for the processor. It's the same story. Now granted, the ratio is not as different. They did put a little bit more, if you put these next to each other, you can see the one for the processor is definitely taller, but it had the same thing going on where that dust had collected and kind of fallen into the inlet. So basically on this heat pipe system, that top was probably flowing 20% of the air it's supposed to. And just because of all the dirt, and you can also imagine, like, because these fins are so close together and they're real short, it's hard for air to flow through that. But the air that does flow through that is going to capture a shitload of heat because you got a high fin density, and look how close you are to that copper compared to the fins on the bottom. So this is just kind of like looking at a part and understanding what the designers were thinking when they designed this. And it's really obvious that that little top section is doing quite a bit of work. It might be taking up 20% of the space, but it's probably conducting 30-35% of the heat just because it's so close to that copper. That bottom section where it's really open and lots of air can flow doesn't really do a lot, because any heat, like say this bottom wall, see how there's a fin that kind of pokes up a tiny bit? Say that little fin that's poking up that tiny bit conducts some heat, right? Well, for that, for more heat from that copper pipe to get to it, look at the path it has to travel. It has to go from copper to aluminum, go all the way down across the bottom, and then back up to that fin. So that distance is probably, it's huge. Whereas on the top fins, that distance is just tiny. The biggest distance it has to go is 1/8 of an inch. And most of it, the average is half that, a 1/16 of an inch. So this gap is just so tiny. Now, here's the last part of this design that's important to understand. When you put a fin like this and you make the air path restrictive, right? Because that channel has a ceiling and a floor plus a fine pitch density, right? So it's going to be hard for air. It's not going to want to travel through that. This bottom one, you can see it starts off that way and then it opens up. So you're probably thinking, well, great, how the top one is probably just too restrictive for airflow. Well, look what they did. If I spin this around, on the bottom, this floor goes all the way to where my fingernail is. But notice the top, they catty-cornered it. This air can exit right here where my fingernail is. So this has a shorter path to travel. And if you look at the copper that's coming into it, you'll see what I mean. these two copper pipes, basically right after where they stop is where this fin stops. So by doing that, they kept that top section shorter. So even though it had a short ceiling, it had a short flow path as well. And that definitely would have helped the air that can go through to get in and get out with as minimal drag as possible. So kind of a high performance section of the heat exchanger up here, but it's more sensitive to dirt than this bottom section was. So that's kind of the downside with a system like this, the way that was designed. I'm sure they just did it for, they said, hey, this is a performance. This is an old computer, but this was a high-end gaming computer back when it was built. So they were probably going for performance, So now that I've seen this, I understand how this works. I know that probably every couple of years you need to, if you really want your max performance, you probably got to take this thing apart and clean it. But I thought that was interesting, understanding the design of these. The last thing I'll mention, just for those of you that are curious, these are old parts. I can't remember exactly how these work, like exactly, but they put something in this pipe. And basically it's kind of like a refrigeration system a little bit. The stuff that here, when you heat this up, it kind of like boils off as a vapor. The vapor travels over here and cools off and condenses. And then that liquid runs back. It comes over here. And when the liquid gets here and you heat it, it boils off, turns into a vapor, travels back again. So it's like a little mini refrigeration system. So even though these pipes are made of copper, the copper itself, there's more to it than just this being made out of copper. So that vapor boiling off is what cools all the copper, and then that helps too. But anyway, I wanted to make sure these were working, so I basically took a lighter and I put a lighter in just that little square there, applied some heat carefully, and the copper barely heats up, but you could literally feel these heat exchangers heating up. And I tried to apply like here, like I heated this up for a few seconds and it was getting hot over here, or warm, and these were about the same temp. So it definitely still works. And even this little bar, I only noticed this a minute ago. So this thing has a whole, this pipe here and this pipe doesn't really go to that. It just goes here. So this loop kind of does like this to cool the GPU, and this one does the GPU, right? And then this also catches some heat from the processor and brings it all the way over here. Or you could take heat from the GPU and move it here into that heat sink. But there's a whole separate tube right here, and all it does, it doesn't catch this at all. It just follows this and then this metal here. If you look under here, all these little squares, these two on the far left over here, if I come down, is this row. And it looks like those are actually, they're called out as capacitors. That's surprising. I don't know why a cap would need cooling like that. Oh wait, maybe I'm looking at that wrong. Sorry, my bad. The caps do get cooled by that middle bar. So this is the edges. So that's these two squares here. That square and that square. Not quite sure what those are, but whatever they are, they must be important to have a dedicated cooling pad going to them. And these didn't have, that tape and stuff was very poorly done. So I'm guessing that by redoing all of this, yeah, this is going to run a little bit cooler. This is probably going to run a lot cooler if I manage to fix these two broken holes. But all these other things like processors and, not processors, like power supplies and various things like that, those are all going to be getting some extra cooling too. So overall, the temperature of all this stuff should be coming down, which is good for stability, reliability, and maybe it'll run a little faster too. So thought I'd show y'all some of that stuff. Till next time, y'all take it easy. Well, this is our shot. We took JB Weld and threw that on here, and this is what we got. Hopefully it works out. We cleaned everything super nice. I have this 99% alcohol, and we used like Q-tips and just went in there and cleaned the studs, cleaned the holes. And we use JB Weld. So the company I work at, we use this stuff quite a bit as an epoxy. JB Weld has a lot of good properties, and one of them is that it's affordable compared to like some of these things are $100 an ounce. This stuff's like $5 or $10 an ounce. It's a lot cheaper. But anyway, we cleaned everything, and when we put it in here, we put a little extra. Like, we did the diameters, of course, so those two are real close together, but we can see we kind of spread this out. And like right here, I'll try to get that to focus. You'll see there's a couple of small components there. I didn't put it on those, but I tried to put it around most of the other stuff. And especially on this one over here, you can see, looks like we actually dabbed some on a resistor by accident. I'll clean that if we did. But basically, we just kind of run around the components. And that gives us a little bit extra surface area. And I think we can kind of use all we can get. So when I put this together, I'm going to be super careful recognizing that these are not going to be that strong. So I'm going to try to very carefully, just gently, slowly tighten the screws a little bit. Some of the force is going to be getting pushed on these and these pieces over here. And then, of course, the rest will be on the processor. So we're just going to very carefully and slowly pull that down, and then that's it. Try to get it decent and recognize that we can't get super tight or we're just going to break these off the motherboard. In the event that we do break them off the motherboard, I looked it up. I can get a used motherboard for about $140, something like that. So it's not the end of the world. If I did trash this motherboard, I could get it replaced. It'd probably be worse having to take all this apart and put it back together. But anyway, this is our attempt. Hopefully this works. So wish me luck. All right, so today's the day after. We glued all this stuff down. The JB Weld is cured. I've already put some of this thermal pad stuff down. We're getting ready to reassemble. Just bought these little packs from Amazon. Who knows? There's something. Hopefully they're okay. But getting ready to put it back together. So we did bolt down this heatsink. We went ahead and put it down once and tightened the bolts, and everything seemed okay. We were able to snug them a little bit and then took it all apart, and everything's still solid. Nothing happened. Felt good. So now I feel a little bit better that this is going to work. My only concern is that when I didn't have the thermal pads at the time, so when you do put the thermal pads, you're going to have to squish those as well, and that's going to put a little extra load, but we'll just be careful and hopefully this works. So yeah, at this point, you can see all these old ones. These are all the old ones that came off. And this is why I took it apart before I ordered stuff, because I kind of knew that I would have to see what I need, because I just don't do laptop repair. So these are actually different thicknesses, and I got lucky. I found a little pack that has both. So these are 1 millimeter, and the others are like 0.5 millimeter somewhere. Anyway, so we're just kind of going around putting these. So for this one, it's pretty easy. You just do these three here. Heatsink compound, and then this little thing bolts down. So we're about to do that. This is the one I'm worried about anyway. So we're going to do that. Hopefully it goes well. And, actually you can't bolt it all the way down. So you put that one in. Funny enough, you have to put the second one on top. So I guess we really won't know how well it worked until we finish everything. That's a little frustrating, but nonetheless, we're going to carry on because I need my computer. So I'm going to knock this out. Hopefully everything goes smooth. Okay, so we just got done putting all our heat sinks back in and dropped the fan back in there, and it went okay. So basically we had to set this piece in here real nice and careful, try not to mess up our thermal compound. Then this heat exchanger went in after that, which this one ties into that one through some thermal pad. And so we got everything clicked in. It all went pretty good. Put these screws in first over here, and then we did this one afterwards. And these two are fully screwed in and bottomed out normal, and it all worked. Everything's still stuck to the board. We didn't, it's all tight. Everything's good there. The only question is how durable will it be? But I'll have to be honest, I think JB Weld's a pretty good epoxy. I've used it a lot, and I don't think this is under a huge amount of load. And my guess is that in reality, once you thermally cycle this thing some and it heats and cools, I bet you a little bit of this will relax and the peak stresses will come down. So basically, if that repair holds up for a few days, it'll probably hold up for a long time. That's my thought. JB Weld does really good with temperature. It is slightly ductile, and it's probably not under too much of a load because I was able to spread this out and kind of stick to the surface a little to give it some surface area. So I think we're going to be good. It looks so much better too, and I don't think I filmed this, but see this like tiny little strip here? There's one under here that if I lift this, you can kind of see it. But that just kind of seals some of this stuff up a little better. That's the way it was from the factory. This one seals, there's a plastic piece that comes down. There's also one underneath on the bottom. I did those as well, just replaced them. So hopefully this is kind of put back to like original spec. And we're about to throw the rest. There's a cover over there. We got to put that on. So we're going to hook all that, basically just snap everything back together and pray to God that we didn't break it, and then also hope that we fixed the thermal problem, or at least improved it. So I'll let y'all know how that went. Alright guys, so to wrap this video up, we did get our computer put back together, and it's working excellent. So this is an app I have that shows temperatures. Now I have the fan on max speed. I wanted to see, like, if you use the computer in the real world, like how hot it would get. And look at this. Our maximum temperatures are in like the 60s. You know, 66 is the highest one. Man, this used to be 99 no matter what. And yeah, it's so much better. You can see all these temps are pretty low, and I've noticed this power number's higher. This used to never go over 14 ever, and now it's been bouncing higher. I've seen it go, yeah, right there, look, 35. Like, it would never do that before, so definitely running faster. I'm gonna try one last thing. I don't know if I can do this on camera, but let's see. Yeah, here we go. We're gonna open up Fusion. This will probably strain this. Yeah, look, 47 watts. This is a big program to run. But we'll see if the temperatures go any higher. But you can see we're sitting around 30, 40 watts all the time. Yeah, it's doing good. So that's awesome. Usually Fusion takes about a full minute to load. So I don't know if it'll go, hopefully it'll go faster since this thing seems to be, at least it's pulling more power. Maybe it's, oh wow, yeah. It's already opening. Okay, I didn't really time that, but it seems like it was faster. Anyway, I guess that's a success. I'm very happy that this worked out. Now my, hopefully this thing will be working for a while. Alright, y'all take it easy.